Today we are going to have our first lesson on construction. Constructions is a very important part of the history of geometry and the development of geometry. So, we've got a compass of some sort, we've got a ruler, although I'm going to call it something different in a minute, and then you have some sort of pencil, maybe an eraser. Okay, so let's talk about why we're learning this first. I always get asked this question, why in the world do we need to know how to use a compass or construct things in geometry? So, when the Greeks were formulating, like literally what we learn in math, the postulates, formulating how shapes relate to each other, formulating how the altitude of a triangle compares to the perimeter, when they were making all of these theories, postulates, and ideas, they used tools similar to these right here. Now, theirs might have been 2 sticks with some string tied around it, and they did it in the dirt. I mean, I don't really know. But they used tools similar to a compass and a ruler. That's how they developed geometry. So to be able to understand a subject better, you have to understand where it came from. You have to understand how it was developed. So why do we use constructions? They give us way better insight into the concept we learn in geometry. Instead of taking it for granted and me just telling you how it is, you're going to learn how they're related with these tools. And then they also help us draw things when we can't directly measure something or it's not appropriate. So they help us come up with ideas that we can use in parts of the world and applying to real-world applications that we can't actually measure with necessarily our measurement tools. So, in geometry, in the development of geometry, we call this a compass, and we call this a straight edge, not a ruler. Because when you're developing the postulates of geometry, you can't use the markings on here. You can't just measure. You'll find out why in a minute. You cannot measure because we're going to come up with everything using only a straight edge and a compass. I had an entire college class on geometry where I was only allowed to use these 2 tools for all of class. No rulers, no other tools. I had to develop and come up with things using these tools. Pretty cool. Okay, so what shapes can we draw with a compass? We don't have a lot of time with this, but if you're watching this video or you're at home, take some time to just get your compass out and just start playing with it. Just start drawing some shapes on your paper. So, for example, when you are playing with your compass, you're going to put pressure on the needle and you're going to lightly let your pencil touch the paper. Where does the pressure go? The pressure goes on the needle. So I'm going to call this part a needle and this part the pencil when I do it. A lot of students find that they don't like twisting the compass. They would rather twist their paper. So if you put your needle down and your compass stays still, you can just move your paper. And this is blurry, the focus isn't working. But you can just move your paper instead of moving the compass. So if I put this here, look, I'm twisting my paper, I'm not moving my compass, not moving my compass. Okay? So you play around with it, make some circles, and figure out how to make nice solid circles without your pencil kind of skidding, you know what I mean, kind of skipping, and make it like jagged arcs instead of perfect arcs. So, the reason that we use compasses, and the reason that really the main thing that a compass does is constructs a circle, is because we use those circles, and we use those circles radii to construct congruent segments. So we use the fact that we know if 2 circles are congruent, then their radii are congruent. We use the fact that those radii can help us construct things like equilateral triangles or a midpoint of a segment. So we're using the fact that we can create a circle, and then if we create 2 circles that are congruent, their radii are congruent. So that's the main basis of constructions for us. So we are going to skip that part. We need to achieve 3 things today. We need to learn how to copy a segment, we need to learn how to add segments, and we need to learn how to bisect a segment. Copy, add, bisect. Let's get started. You are given segment AB. This is on one of your papers. And it says copy this segment onto ray A prime. Well, we don't know the other point. Here's what you can't do. You can't measure AB with a ruler. Oh, that's 3.9 centimeters, and then go to the ray and say measure 3.9 centimeters. Remember, this is not a ruler. This is a straight edge. You're not allowed to use the markings and constructions. So the way to copy a segment with a compass is you put the needle on one of the endpoints. You put the pencil on the other endpoint. And then you hold your compass secure. It shouldn't be opening and closing. It shouldn't be changing its position. You take that exact same compass setting, you go down to your ray, and you put it right there? No. You put the needle on the end point of the ray, and you make an arc. You're not done. That is not your answer. A lot of my students stop there and they go to problem number 2. No. Where the arc intersects the ray, that is your new B. So we don't call it B, we call it B prime. I have now copied this exact segment. Let's check it. If we had patty paper, like tracing paper, we could check it perfectly. I have now copied that exact segment onto my ray using a compass. So I know now that segment AB is congruent to segment A prime, B prime. I forced them to be congruent. This is my new segment. This is my answer. So that's how you copy a segment, okay? Let's all do it on our paper. So you're on your paper. You're putting your needle on A and your pencil on B. And my hover crayon is blurry. Come on, yes. There we go. Needle on A, pencil on B. And then you move it down here. You make an arc. It doesn't have to be drastic. You're not done. The intersection is B prime. And if you think about it, like I was saying before, how constructions are all based off of radii, the radius, if this was a circle, this radius would equal, if I went full circle, the radius of this circle. And that's what constructions are driven by. Okay, that was a super, super quick example of how to copy a segment, but that's the easiest one, so we should be okay. Now let's talk about how to add segments. If I called this number 1 and I called this number 2, which one would represent segment AB plus segment CD? Number 1 or number 2? Who did the correct construction? Good. Now they both did something. They both copied AB. They copied AB. But then this student copied CD. And they put it in the wrong spot for addition. When you're adding segments, you want your second segment to start where your first segment ended. So if I construct a copy of AB here, this is my copy of AB, when I construct a copy of CD, I need to begin where AB ended and then place my copy of CD adjacent to it, next to it, collinear with it, not overlapping. So you want them to be, they'll share an endpoint, but you don't want them to be overlapping. So let's try on the back of this other worksheet. It says part 3, add segments. So this says construct MN such that MN equals 2AB. So it's really just saying do AB plus AB, right? That's saying add AB to itself or double AB. Now, if you notice, they didn't give us a ray. When you don't have a ray to start with, You need to go ahead and draw yourself a ray, somewhere to put your answer on. I'm not going to make it horizontal on purpose, because sometimes they're not. So if they don't give you a starting point, you need to put one there yourself. That's not your answer, that's just where you're going to place your answer. That's like the answer blank. Okay, so I'm going to double AB. I'm going to add AB to AB. So step 1, I'm going to open my pencil and needle to the end points. I'm going to come over to the end point, and I'm going to make an arc. That is not my answer. I'm going to go where the arc intersected the ray. I'm not going to change my compass setting, and I'm going to make one additional arc. It said to call our answer segment MN. So I'm going to call this M. I'm going to call this nothing, and I'm going to call this N. I have now constructed segment MN such that MN equals 2AB. So I have doubled AB. I have added AB plus AB. So this is like AB plus AB, segment AB, segment AB. Okay? So if we had time, you would try number 2, and you would add all of those segments together. Pretend we had time, you would put like P here, and then after it you'd put Q here, and then after it you'd put R here, and then your answer would be from end point to end point. This whole segment would be your answer. But we're going to go ahead and move on to the last concept of the day. Let me go through these. All right. To me, this is the most important concept of the day, and this is my favorite construction ever. Okay? We're going to construct a perpendicular bisector. It will be, Catherine. So, here's how you do it. Watch me do it twice, please, and then you can construct it yourself. Watch me twice. All right, so we're going to take our compass. We're going to take our compass, and we're going to put our needle on the end point. Now, where are we going to put the pencil? Here's the deal. I need you to put the pencil more than halfway across the segment, but not past the end of the segment, okay? So like this is not going to cut it. That's not more than halfway. Now, I'm just eyeballing the halfway. No, don't take your ruler and measure halfway and then make sure you go more. No, that would defeat the purpose. Do not do that. Instead, eyeball what you think is halfway and go past halfway. Doesn't matter how far past you go. Just don't hit B. All right, so I went more than halfway. I'm going to make a nice big arc. Almost like a semicircle, almost like half a circle. It doesn't hurt to go more than half a circle, but half a circle. Now I'm going to flip my compass over, and I'm going to put my needle at the other end point. I'm not going to open or close my compass. Don't change the setting. Don't make it wider or narrower. Keep the same setting, and make an arc when your needle is on B. Notice that my arcs intersect. They intersect twice. You need to have an intersection above and an intersection below. When you have both of those, then you can take your straight edge, not your ruler, remember, you can take your straight edge and you can connect them. Pretend Miss Tanton's using a straight edge. Never do this freehand. Always use a straight edge. This is called a perpendicular, add a box, bisector. Add tick marks. Add a box for 90 degrees. That's what perpendicular means. Add tick marks for bisector. That means cut in half. Okay, I'm going to do it one more time on my paper if you want to see it again. If you feel ready to try it, then go ahead and try it. We're on our other paper right now. Construct the midpoint M of CD. So we're going to construct the midpoint. That's the same as the perpendicular bisector. It's going to get us a midpoint. I'm going to open more than halfway. I'm going to make a big arc and kind of mess up my whole paper. It's going to overlap things. That's okay. I'm going to go to the other side. I'm going to go to point C now because I haven't done that one yet. And I'm going to make a big arc. Now my arcs intersect twice. If they don't intersect twice, you need to try again. So now I'm going to take my pencil and my straight edge, and I'm going to connect intersection to intersection. I'm going to add a 90-degree angle marking and tick marks. Perpendicular bisector. So 90 degrees and cut in half. Now, we're not quite done because it said construct the midpoint. Where is the midpoint? The midpoint is where the perpendicular bisector hits the segment. There you are, M. You're right there. M is the midpoint of CD. Okay, I want to ask you guys a question. I'm going to pick a random spot on my perpendicular bisector. This is a random spot. Nothing special about this spot. There we go. I'm going to call that point A. How does the distance from A to C compare to the distance from A to D? So how does the distance from A to one of my endpoints compare to the distance from A to my other endpoint? How do those dotted lines compare? Same, equal, congruent. Could we check that? We could measure it with a ruler, but we're not allowed to use measurement on our ruler. Okay. We could use, this is called tracing paper or patty paper. We could get us some patty paper, and we could trace this segment, endpoint, endpoint, and then we can take our patty paper, dun da da da, and go over here. Oh my goodness. Look, same length, congruent, equal. Is this point unique? Are there more points like point A? Is the same true for this point and this point and this point? What about this one? What about this one? What about this one? What about this one way up here if it lied on that line? Let me make this a line. It goes on forever. So what is true about every point along the perpendicular bisector? Every point on the perpendicular bisector is, that's a fancy word, equidistant from the endpoints. That's really the whole lesson on constructions. We could do some more perpendicular bisectors if we wanted to. I'm going to go ahead and go on the back of this paper and show you one more problem. And that's the end of our construction lesson. I'll come back to this if you didn't have time to write that down. I want to do one more with you. Divide segment AB into 4 congruent parts. Well, I'm going to start by dividing it into 2 congruent parts and see what I can do with that. So how do I divide something into 2 congruent parts? I bisect it. I cut it in half. So I'm constructing the bisector. I've now split it into 2 congruent parts. How would I split it into 4 congruent parts? Good, good. If you half the half, you get a 4th, right? I have 2 halves now, and I'm going to halve the half. I'm going to half it. Okay, so that means I have to do this 2 more times. I have to take this segment, actually I'm going to call this the midpoint. I'm going to take segment MB, and I'm going to bisect it. What do I do first? I open it more than halfway. What do I do next? I put my needle on the midpoint, and intersect. They will intersect twice. They will not intersect once, twice, above and below. Intersect twice, not once. So there we go. Now I do it again over here. Go more than halfway. Make an arc. It's getting messy. More than halfway, make an arc. They intersect twice. Connect. And wow, I have split my segment into 1, 2, 3, 4 congruent parts. All right, and if you're fancy like me, my pen's erasable. Oh no, that's really ugly. So anyways, you could erase your markings if you want it to really look pretty. But Miss Tanton actually loves the markings because the markings show that you didn't use a ruler. They show that you used constructions instead of a ruler. So I actually want you to keep the markings there.